now I'm not muted on Twitch anymore. What would be great is if someone of the other core developers could come up on stage here and try whether, well, if someone else is speaking, the voice is also properly propagated. Speak again, Chris, sorry. That's curious, interesting. I feel like you might not make it through my... Yeah. No. You're definitely visible, audible on Discord, but I don't think I have you on... I don't think I have you on my stream, which is weird. I think I know why. Let me quickly fix that. Hi, everyone. Yes, excellent. So you should, everyone here in Discord should be able to hear everything anyhow, and the people on Twitch and maybe also for the recording should be audible in my stream also in a moment. Could someone try to talk again?
Yes, I do attempt to talk.
Yes, the bar is
surprisingly difficult to think of garbage to talk about.
Yeah, that's always the stuff with technical setup, right?
Yes, it is.
Okay. Yeah, I think it works now. Thanks, Daryl. Thanks for checking on the other side. Talk about the economy. I prefer not to. Chris can be a bit louder. I can increase volume. Okay, now you hear exactly the same thing that I can hear. Should be fine now. Okay. So bear with us for like a moment longer until we have everything set up, and then we can start this meeting. Yeah, Twitch is lagging slightly. That's the way it is. Just mute me on Twitch and everything will be fine. All right. It's already past 2. I do fetch myself a quick cup of coffee and then I'll be back and we can we'll start this. Sorry for being a tiny bit late. Well, technical difficulties, let's say. Be right back. Someone else entertain the crowd in the meantime.
Entertain the crowd. Maybe I can tell a funny story. I wanted to prepare something for the show today with Maki, and everything was working until an hour ago. Everything broke down. We'll see if it's still working today. Now. But yeah, we'll see about that. Really, do I have to be the only one talking right now? Apparently. Daryl, did you start the recording or is Benjamin doing that? Well, if you think so. Well, the problem is I really don't know what I'm supposed to talk about. I mean, all of the important topics I can't talk about without Benjamin.
Benjamin is back.
The weather.
The weather?
Ah, welcome back.
Thank you. Sorry,
For all the,
apologies for the delay. And I just don't work without coffee, so. Okay, let's get started. Thanks everyone for showing up. I hope this will be fun. Wait, what's happening here? Okay. Please, I need you to be kind to me today. There is like 3 different things I have to look at the same time, and I will probably fail and become incomprehensible at times. Please just interrupt or ask for clarification whenever something gets too, I don't know, whenever this derails too much. I think we can just start the meeting now. We have an agenda which we sort of also sent out. Wait, I should also give you, in case you want to look at these slides in your own window and not just on my Twitch thingy, there is also a link to these slides, so you can skim through them in case there's something particularly interesting. I have no idea how long we will be talking about the points, but one thing that I do know is that I want to keep the first part where we briefly give you some updates on the Manim Community organization. I want to keep that rather short, so like 10 minutes or something like that, and then everything else will be, I think we will be discussing rather technical things today. And well, in case you have any questions or comments or whatever, I'll say that actually on the next slide as well. So the 4 points, or the 3 points actually, that we have on our agenda today is, well, some updates regarding the organization, a few discussion points where we should talk about the overall goals for Manim, the library, and finally, the third thing will be, well, the main thing actually, which is we will discuss the road to our first stable release, the road to our first to our Manim v 1.0 release. And then, of course, the space is open for any sort of discussion, and please don't hold back. Ask your questions whenever you feel like it's the right time. And yeah. So, oops. How does the meeting work in general? I've already mentioned there is no screen sharing in the Discord stage channels, unfortunately, which means we have to do it slightly complicated over my. I offered to do it over my Twitch channel and no one opposed, so we'll do it like that. I'm sitting there. Hello. And if you're listening in over Discord, then I recommend muting the Twitch channel in case you want to have something to look at while we are talking. If you're fine with just audio, then please, by all means, the Discord channel is just fine. Otherwise, I hope this meeting will have a rather relaxed atmosphere. We will have me talking, as well as other core developers who will give input to several items on the agenda. Everyone is free to comment on the things that we're going to discuss, of course. And yeah, please actively participate. We will probably ask some, maybe do some polls or something like that in the meeting chat channel. And I hope others will also help me to monitor all of the different channels that we have, because it might be a bit difficult if I can easily lose sight of something. And to participate, just to be very explicit what that means, either request that you come up on stage in the community town hall channel and speak with us, or use the meeting chat channel, or you can also try to do it on Twitch chat. I will have an eye on that and relay your voice somehow. Yeah, and that's basically it. Any questions so far? Are you excited? I'm excited. Also, my coffee is too hot to drink, which is unfortunate, but well, that's how life is. Let's start with some updates from the community organization. One thing, so you might be wondering what is even the community organization. Basically, it's this loose collective of core developers, so the people that contribute code more often to the GitHub repository and to review the changes that you guys might have submitted in the past. And one thing that we did over the past few months is we decided to establish a more formal governance scheme, because in the long run, we'd like to try to apply for funding so that we can maybe afford fancy features that just doing this as a open source project without any source of funding could have. So, for example, I actually have points on the slide, so I don't have to invent something. But the important thing before we go to the why we need funding is the governance scheme includes a former steering council, which has been elected by the core developers a while back, actually last month or so. Anyone correct me if I'm too wrong now. And the steering council currently consists of 3 people, namely, oh, that's very bright. I'm sorry. Namely myself. Then there's Naveen and also Daryl Golden. We're in the initial steering council, and the plan is to have yearly elections amongst the core community developers. Basically, the steering council is responsible. That's the job of the steering council. You can, of course, go through all of the precise. You can, of course, go through all of the details of what the steering council does and does not do. I've posted the link in the meeting chat and also on Twitch chat, I guess. Why not? Yeah. So in case on Discord, it doesn't matter so much because we have a rather large moderation team now. But if there are any issues, then feel free, especially with the organization itself, then feel free to come up to the steering council, and we'll deal with everything appropriately. Also, thanks to Chris for moderating the election and organizing everything. That was helpful.
No problem.
One thing that I'm very excited about is a while back we applied for being an affiliated project to NumFocus. In case you don't know NumFocus, I'll click on the link again. Careful, that might be bright again. Yes, indeed it is. NumFocus is like a. I'll open their about page and then maybe I read less mumbo jumbo. Basically, they're an umbrella organization that helps open source organizations become more structured, helps them be connected to each other, and also helps them with funding. So, for example, they usually serve as an umbrella corporation for the Google Summer of Code program, which you might have heard of before. And yeah, they do all sorts of nice things for projects, and I'm very, very happy to be able to announce that as of, I don't know, last month, we're officially an affiliated project of NumFocus. So if you go to the NumFocus page, scroll down the list of affiliated projects, then you will see here Manim, which is, well, nice. And I think congratulations to the entire community and everyone who worked on that to make that happen. I think this will be very useful in the future. In particular, one thing that they allow is they allow us to submit proposals for small funding for small projects that are then funded as well. So yeah, might be the option to have, well, stuff. Let's see. Yeah, regarding funding, now I've mentioned it several times. To give you some more details about that, this is still, and don't get me wrong, this is still a project that is run entirely by volunteers. None of us are paid for doing this. And I intend to keep it that way. So for now, at least. We are definitely not doing this for the money, but it seems that for some, in some instances, we do need money. For example, some of our current expenses are the Manim Community domain, which also serves our documentation, and in parts also the Manim Discord bot. So we do have some resources that we need that are not easily available purely from open source. Currently, these things are just donated by core devs, these resources, but eventually it would be nice if we could fund them out of the community. And in order to do that, we have organized an Open Collective account, in case you have not heard about Open Collective before, which might possible. Sorry, all of these websites are very bright. Basically, this is a bank account, an open source bank account. So we have something where we can pay donations to and pay expenses from in case we need it. As of right now, we don't really have that much expenses that we have to be very aggressive when it comes to advertising that there is an option to donate to the project now. But eventually, in case we commit to something that actually requires some sort of periodic funding, then we might have to do that. No real plans as of yet. We have some ideas what we could use additional funding for. So stuff like a proper server where we could also host the bot on. We've ran into issues with the documentation several times, so a dedicated machine could help to resolve that, maybe. We have talked about some sort of backup plan for our GitHub, I think. Not the point of Open Collectives to be completely transparent with funds for people not familiar with. Yes, exactly. So we don't intend to hide anything. We are completely open in how eventual funds might be used. So yeah, and that's what Open Collective helps us to do. Yeah, so backups, maybe also a paid GitHub plan for more CI power. Recently, we've started to run into an AP rate limit stuff, and I'm not quite sure where that actually comes from, but yeah, money could help to resolve some of these issues, but in some cases also requires us to put more work into things. So it will be a difficult road to balance. Eventually, and this is far down the road, nothing that will be achievable in the in intermediate future. But eventually, it would be nice to have funding for maybe even paying a part-time developer or a full-time developer who works on the library, because that might help speed up certain things that the community has struggled with for a while now. We'll come to that as well, don't worry. Actually the main part of the meeting. Okay. One thing that I do want to make an open call for, so to say, in case you know of any other funding opportunities for educational math software, please let us know and just drop it a message in one of the channels so that we know and can try to pursue it. If it's something that we can realistically get, then this might speed along. This might speed up feature development and stuff. Any questions so far? That's most of the things I want to talk about for the community. Sorry if this was really, I don't know, fast or incomprehensible in terms of what the steering council is or what the organization actually is. More or less, this is still a very loose concept in some sense. GitLab is maybe cheaper for CI. I would have to investigate. I know that both GitLab and GitHub by now allow you to host your own runners, but I'm not sure whether that would circumvent the AP rate request thing that we've been running into. Okay, if there are no further comments right now, then I think we can move on to the next part. JSO is maybe typing. Let's wait a moment. Where should I start contributing? I think this is a question that we'll answer separately, and maybe someone could link our contribution guide. I'm sure someone is already searching for the corresponding link. And thanks for wanting to contribute, of course. This is very welcome. Everyone is very welcome to, try to make this a better piece of software. All right. It's time to so this is something that the past part was something where I give you updates from what's been what has been happening, and now this next part and also the part after, these are where I would like to get a little bit more input from you guys listening in. For the first part, it makes sense to discuss a little bit what the goals for Manim, the library, actually are. We've had a similar discussion internally a while back. And one thing, it's a bit hard to summarize the entire state of affairs. Maybe something that summarizes it quite well is we want Manim to be tech for mathematical videos, basically. So LaTeX, we want Manim to be exactly that, but for animations, basically. This is more or less the state of how most of the core developers think. There are degrees of opinions there, especially when it comes to how far should things be already included, how much should we externalize, should we throw out some of the existing features to make the core of the library, whatever that is, more maintainable. These are things that are not that easy to answer and to discuss, but maybe we can try to do some of these today. Some of the important features that are important to me personally are that I think Manim is easy to use in some sense and also hard to master. It is a sort of batteries included, which is in general a very Pythonic concept of a library, and it is programmatic. These are sort of the main concepts that the library incorporates for me. What do you guys think? What are your core features, like the big conceptual stuff? What makes Manim for you?
I think one of the most my favorite features of Manim is that it has sane defaults. I mean, there are many different rendering systems that require you to, first of all, set up things to tell it. For example, you're creating an object and then you have to tell it the color and the location and many different parameters. Manim has sane defaults for everything. So even if you don't define those, they're already set in a sensible way and in a way that makes sense for most users. I think that is quite important for, especially for this easy to learn aspect or easy to use.
Sane defaults is something that I can definitely resonate with. Yes, there was before one of the first, well, maybe not one of the first, but one of the important differences between the free blue one brown Manim upstream version, if you still want to call it upstream, and our version is that we ripped out all the code related to the config dictionaries, because it basically re-implemented the inheritance structure of classes that is default to object-oriented programming. And I feel like while doing that, we still managed to keep these relatively sane default values for the objects and how things are configured. I think this is something that went very well when moving away from Grant's original implementation. What do other people think? More core concepts. What is important when it comes to Manim? Yes, definitely. Everyone can speak. So just request to be a speaker. We will get anyone on stage here. Manim is the only good code-based 2D animation library in Python. Yeah, that's possible to some degree. Being able to use LaTeX and visuals are pretty good. Yeah. So I think one of the I could summarize that maybe a little as it definitely is meant to be used in the context of mathematics. And this can be a good thing and a bad thing as well. When trying to do completely different stuff with Manim, it might not be that easy, and you might be better off using the default animation tools that are around. Yeah, that was what I just meant. So being programmatic is definitely one of the I put it already as one of my important features or cornerstones of Manim, so to say, because I really feel that distinguishes it from other animation software. Is there a possibility of Manim going the Blender way, wherein there's a real-time user interface along with a coding tab? We've discussed this, and basically the stance of the core devs was, please correct me if I'm wrong, by the way, that as Daryl already wrote, this would be very hard and probably rather a different project. So I feel like we have the rendering engine Manim itself on the bottom, and then if someone wants to, and eventually the interface becomes stable enough, then on top of that, some sort of graphical user interface could be put on top of that. But from the code that is in Manim Community /Manim in this Manim Git repository, I don't think that a graphical user interface will ever, at least not in the Blender way. I would like that long term. Yeah, I mean, if this is if we do public wishes right now, then yes, I would love if we had a nice and clean graphical user interface that can work with Manim. But at this point, even the effort of implementing something like that, I see as a lost cause, because the interface of Manim is simply not stable enough.
If I'm allowed to add something to that,
Definitely.
this is touching the entire topic of interactivity, I think. Something Evan has worked on and Manim supports to some extent at the moment. That is actually something I'm currently experimenting with Maki. I can show you a few things in a moment later on when the time comes. And with Maki, I'm putting interactivity into the center of the entire project in a way. Because I think, well, first of all, people apparently want interactivity, some form of interactivity. And if we want that, I think we should implement that very, it has to be implemented in the bottom, in the heart of the rendering engine. The people who don't know what Maki currently is an experimental rendering backend from Manim, written by me in C++. It is just a draft. It is likely not going to become any official part of Manim anytime soon. I'm just implementing it to play around, see what's possible, what can be done. And well, one of my ideas was to make everything interactive, so that you can move around in the scene and maybe even change things. I'm not so sure about the changing part, because that is kind of contradicting that programmatic aspect. But at least moving around, being able to look at the scene from different angles might be useful, might be interesting. So yeah, more on that later.
Yes, we will have a demonstration, I hope, in a little while, after we've discussed like the big things, and then I'm looking forward to that already. So Kobodism writes, what are your feelings about the separation of Manim, the library, and the source for a Manim video? Should we make that break clearer? What I would like is if there are certain advantages of users of the current workflow, where users subclass the scene class and then build an animation from there. But at the same time, it also feels silly. Most of the time, especially when doing simple stuff, you need exactly the construct method of the scene and nothing else. So what I've proposed a while back, let me try to find it. Let me try to find it. Is a sort of intermediate thing where you can just specify a function with a decorator, and then that turns into a scene, and you don't need the user to do any work regarding that. I have no idea whether I can find that. Actually, I found it. I'll post it in chat. This here was an attempt of creating something in that direction, but it was not thought through enough, and didn't really. We decided not to pursue this further. Maybe if there's interest for if there's interest for going in that direction, we can make another attempt. Let me just see that I didn't miss any comments. Yes, interactivity. Manim does support interactivity, and I think Aquabeam has worked a little with that, right? Well, I can at least remember that there was some discussion quite recently. Ah, you're up on stage. Do you want to say something?
Hello?
Hey.
Oh, okay. Yeah, so I made a guide that Daryl Gordon just linked in the chat that you can use if you want to get started with OpenGL. It eventually would be moved to the docs, but OpenGL is at least is very unstable and lots of things are changing. So I just made it as a separate blog post on my site. So you can do interactivity, particularly with self.interactive embed, and it wouldn't be unreasonable to make basically have a thing where you could drag and click each object as you make it, but like making it clean and usable is a very different story from it existing. And that's what I mentioned. Like it's technically possible with DRPy GUI. Like theoretically, you could have like a list of objects in the sidebar, and like you click an object, and then you could like drag it around the scene and make changes to it. But that's kind of a pipe dream at the moment.
I mean, it would be interesting to know whether what people think about it and whether we should pursue this further. I do agree that it's slightly contrary to the purely programmatic aspect, but then again, this sort of interactivity and especially being able to rotate the camera around in a scene and stuff, this does help to well visualize things also very, very easily and maybe even iterate on animations a bit faster. Okay. All right. Are there any further comments? Is there something we did not discuss yet of what people said regarding what they feel are cornerstone features for Manim? Plugin system. Yes. Positioning is yes. I feel like positioning stuff in Manim is sort of okay. I don't like that. I don't know. Sometimes I struggle to remember the exact naming of a method, and then I feel like we should unify the naming of all of these movement methods a little bit. But yeah, that's maybe just me. Okay. Let's go on. If there are further comments, we can always come back to this question as well. Another big thing that we should talk about, what should our relationship with our original version, so 3 blue 1 brown Manim, be? To say something about the history, why these are currently separate is basically Grant has no interest in maintaining something that other people software that other people can use as well. And while he's definitely thankful for contributions to his version, it's this will always be a moving target. So he will implement features that he needs for his videos, and he will merge them, and then they are in there, and then when he does something else, they might break again. This is just the way he works, and this is not compatible with producing some sort of stable software that other people can use long term at least. You can of course, if you say you want to render some specific video that Grant worked on, you can always go to the code he posts in his video repository. You can search the exact commit that of ManimGL or whatever he used to produce that, and then just compile the video and it will work. But yeah, there's no stability of any of this, which means that actually just having one version of our two softwares, also merging them back together, is to some degree unrealistic. We could say, well, Grant works on some separate branch and he does things there, and then whenever he's done with something, we try to incorporate it into the stable version of the library. But I feel like this, without someone actually working like at least part-time on the project, I don't think that this is a reasonable approach. What do you guys think?
Yeah, I tend to agree. I mean, I came to Manim not even knowing the entire history of how this community got created. And to be honest, I kind of feel like Manim CE is quite a self-contained product. And I don't really see that many connections to Fleet Blue and Brown anymore. And that going back to, well, combining Manim GL and Manim CE again is not something I'm a huge fan of. I think we've outgrown Grant. I think so too, at least in some aspects.
Yes, I feel like sometimes people submit really useful pull requests to his repository because they want to contribute to the library made by Grant. And this is perfectly reasonable. I mean, he is popular on the internet, and therefore it's perfectly reasonable to have lots of people wanting to contribute to your piece of software somehow. But I do also tend to agree that this project has become something separate, and we don't necessarily need to stick so close to Manim GL. The thing that is useful, though, sometimes people do contribute interesting stuff there. So, for example, recently there was a rewrite of the Techm object, which works, I think, better than what we currently have. And this would be interesting to port over to the community version. If we said that we break the interface completely and nothing is nothing is the same anymore, then I feel like it would be difficult to port stuff over that is submitted to Grant's repository. However, I don't really see the danger of this complete break. I feel like the general user interface that people use to create animations, the general external API is not that bad. I feel like the way how things work, object, scene, camera, renderer, this is not bad. Just the implementation, everything that's internal, that's really, really bad. But we'll come to that in a bit. How come Euler is not in the governing council? He did not. He did not run for a seat in the steering committee. But he's of course still a core developer, and also he's part of the maintainers of the repository. So he's still around. Okay. Yeah. The thing that's unfortunate, of course, with this differences in the between Manim and Manim GL is, of course, that it's hard to explain. So we have two completely different versions of the same software that's basically called Manim. And actually, there's more than two versions if you dig a bit deeper. But yeah, this is unfortunate, but I don't see a way around it. the way I've been doing things recently regarding which version to recommend is I usually recommend the community version, except if someone says they explicitly want to use OpenGL and interactivity, then I usually point them to Grant's version. It's not uncommon for open source projects to have multiple versions. That's definitely true. Yes, there are many examples, many examples. Let me quickly check. I've been pinged somewhere. Oh, but this was somewhere here. Could you so if someone says they explicitly want to use OpenGL rendering and interactivity, then I usually point them to Grant's version. Or if they generally express interest in rendering the code that Grant uses in his videos, then I also point them to his version, obviously. Let me quickly turn up some light. Be right back.
Yeah, I got asked if the interactivity part of Marky is anything like P5.js. And to be honest, I have no idea. I've never heard of P5.js. Some kind of interactive way of creating code, if I'm not mistaken. Oh yeah, OpenGL. Well, the problem is right now we are using mainly Cairo to render things, and Cairo is inherently 2D. And to be able to support 3D, we need some kind of rather interesting conversion layer from 3D to 2D that Grant has written. And if we are using OpenGL, everything is, well, mainly 3D and also supporting 2D, which makes things a lot cleaner and, well, also faster. But then again, OpenGL is old, hasn't been updated in 5 years, and it has already been deprecated on Macs to some extent. So if we really want to rewrite things, we should do it in a way that allows, well, the future community to implement a new API, like Vulkan or DirectX or Metal, if that is required, which it quite definitely will once OpenGL is completely deprecated everywhere. Okay, I got an example for P5.js.
Okay, I think we can leave the question regarding our relationship to ManimGL behind for now. If there are further comments, please feel free to well, send messages. Let me just check that I didn't miss anything. Yeah, okay. Some more general questions now that you're all here and listening in. Do you see, and this is maybe something that we could do as a poll here. Let's see, is Manim 2D or 3D for you? 2D. Yeah, I suspected as much. I feel like no 4D. I mean, many objects are designed to be used in 2 dimensions only, and this is one thing that we have to keep in mind when we move to, well, any other rendering or camera system, that people primarily care about the 2D version of things. It's nice if we manage to make 3D compatibility great, but if we break or make 2D animations worse by doing so, then I'm not sure whether it's really an upgrade. I just want to do 1D animations one day. Yeah, 3D is very slow. I mean, we will see how that works out. Interactivity. How do you feel about interactivity? Interactivity is not needed. Or you should do a poll again. Let's do. Oops. Oh well, that worked out well. What do I mean by interactivity? You can render a scene and then, for example, manipulate the camera of the scene in the window that pops up, or move objects around, or yeah, that's also pretty much what I expected. I mean, Manim can do this already. It's always just a question how much we should focus on well, developing these features further. I like to use Manim for making slides for a conference. I'm able to pause the video at specific points and advance to the next video I'm clicking. Oh, that you should check out Chris's Manim editor, which is really great. Ah, yeah, Daryl already wrote that. Ideally for me, interactivity would be like Blender, where it kind of reduces quality when adjusting things, but you can play with it. I see, yes. I feel like that would be difficult. But to be quite honest, I also don't fully know how interactivity works right now. That Aquabeam has probably looked into that a bit more. Okay. And the final thing that I've mentioned here is custom plugins. Basically, thanks for hosting. Basically, Manim has some sort of a plugin system where you can write an external library that depends on Manim and then import things from your library easily when running Manim. That's more or less what we mean by plugin system. There is a link somewhere probably to our plugin page. Maybe someone is faster than I am. Probably someone is faster than I am. Thanks. Yes, so these are examples for what we understand as plugins, and we have thought about moving code out of the mains, the core Manim library into these plugins. So, for example, like yesterday we talked a little bit about what if we moved everything related to plotting of functions, so the coordinate systems and stuff, into a separate external plugin. This would on the one hand, make it an external part, so it would not ship with Manim directly, but you can just install it with one additional command. It would help to sort of allow people that are only interested in developing stuff for this submodule to do their own thing and move a bit faster than the core library currently does. What do you think about that? Any thoughts about well, breaking the library into more plugins?
I
Just a
think that may. Oh, I'm sorry.
Sure, I'll go ahead. Sure. Just how would like documentation work if we were to move, like, let's say, like text rendering and like, plotting and all these other things outside of the core of Mana?
As far as I understand, Read the Docs has an option to declare like a root project, which would be the core library, and then include all sorts of sub-documentations, which means that if you're on the Docs Manim community and you search for text, then you would end up in the documentation of the text module, which is a separate project, but still sort of belongs together. I have no idea whether this works with our recent internationalization and translation efforts, but I know that at least this first part that works. So we can reference sub-projects in our documentation.
Pretty cool.
Yeah, I think that a plugin system is pretty sensible, not just to allow other people to implement their own features into Manim, but to force the core developers to write sensible APIs internally. If other people are supposed to use this, supposed to understand this, without being developers of Manim, then we are forced to write good code that is well, modular and generally sensible. So I think that even if we don't end up using a single plugin in the end, at least having this goal makes sense.
Yes, I think an intermediate step anyhow would be what Daryl just mentions, namely we could try to move the current module structure, which is a mess. Basically, everything is an object, and there are no sensible submodules of objects. We could move that into something that makes a little bit more sense and is a little bit more self-contained and not, I don't know. Yeah, we could try to do that first, and then if we feel like, okay, now we are ready to separate it out, then we can turn it into a Git submodule and whatever. But yeah, that's something we could do. Yeah, we're not. I do want to talk about the mess that we currently have, but not quite yet. In a little bit. Okay. All right. Did we miss any further comments? We extract everything into appropriate plugins. What's left? Whatever we consider the core of the library. Rendering logic, for example, scenes and animations. So you can think of the library as consisting of two separate parts. On the one hand, everything that's related to the actual rendering loop, which processes your scene and does things, and on the other hand, all the things that you put inside of your rendering loop. And the things you put inside, actually, the rendering loop itself doesn't really need to it uses some sort of internal interface to objects, to animations, and it doesn't really need to know the concrete implementations of everything. It just needs to know this animation needs to have a begin method. It needs to have a cleanup from scene method. It needs to have a, I don't know. And like that, you can separate things quite well, actually. Yeah, but I think before we do that, we will need to talk about something else first. Let's see. Okay, this is also an interesting one, and I'm curious what you guys think. Which other Python libraries, for example, Matplotlib is a very big one. Which other libraries would you like to see interfaces to? So currently Manim has a few interfaces already built in. Network X comes to mind, which does the graphs, not as in plotting, but as in graph theory. So we use that already. And there are a few others that we have interfaces to. But what's some big libraries that you feel like the library would benefit from having an interface to? A better SVG parser lib. Yes, I think this is like on the top of my wish list. I don't want to scare you guys, otherwise I would open the SVG parsing code that we have in Manim.
What would also make sense is some kind of SVG export, so that we aren't just able to read SVGs, but also able to save them.
Yes.
That is not just a library we have to support, but more general idea for the rendering.
If we have the means of finding a good SVG parsing library that can do both directions, like from parsing an SVG to creating objects, and the other direction would be from our objects to creating an appropriate SVG. If we can find something like that, then yes, then everything becomes realistic. If we have to do it manually, then I feel pain. Okay, so SVG export, like Reanimate. Yes, Reanimate does things well. To recollect these libraries and be like a sage of SVG rendering. Could we do something other than Manim Pango? What's wrong with Pango? In terms of text rendering, I don't think that we have too many other options, and I mean, Naveen is the expert here, but I think we looked into text rendering quite a bit, and there were not too many options that we can realistically implement. Manim is very strong on the theoretical math side, but rather weak on the data visualization side. Yes, this is what I meant. Manim and Pandas, for example, or Manim and I think Killer Coda had some example. Was it was it Citrus Munch? I can't remember. I think it was Shapely or something like that. So there are lots of data visualization tools out there. The question is, would it make sense to build interfaces to them for Manim? speeding some code up with external libraries. Yes, we should also do that way more. One thing and I can, so this is again one like a historical thing that you need to be aware of. Manim started as a project because Grant wanted to learn programming with Python. And parts of the code exactly look like that. I don't mean this as an offense. This is just how parts of the library look like. And Grant, in very many cases, implemented stuff himself that libraries have optimized versions of. And we should throw out existing code that's maybe import from not really efficient and use proper libraries for that. If you have examples, please let us know which concrete libraries you're thinking of. But recently we've investigated replacing some of the manual BCA curve implementations by an external library, for example. Well, I don't necessarily mean that we should have these interfaces to other libraries as a core part of Manim, but they would make interesting plugins, for example. Yeah, GeoGebra would really be interesting to have some sort of import from GeoGebra files. I feel like that would be interesting. If you run into bugs in external libraries, it's much harder to get it fixed. That's true. That's true. One thing that Sage does in this case is it patches the external libraries with fixes if stuff is not fixed upstream. But I feel like the general problem is well, in most cases we can work around that, I think. Yeah, I also think that in the case that we are using some well-known, well-developed, and actively maintained library, then chances the bug is fixed are actually, well, probably even higher than if it's just in pure Manim. Okay. I feel like this was very interesting. Okay, so some data visualization libraries were mentioned. Anything else that comes to mind? It's fine, we can also move on to the next thing. What about code support? What do you mean? Sage. Yes, I've thought about that quite a lot already. And I've actually also already used that, but yeah. Visualization of arrays and data structures. Yes. I would like one of the biggest pain points, or one of the big pain points, not biggest, of object implementations is probably the code object and the which relies heavily on the paragraph object. Well, and paragraph and code are both really, really messy. It would be great to, well, have those rewritten. Okay, anyhow, so these were some very interesting mentions, and I think we can. What object can be generated per highlight.js? I don't know. We'll have to investigate, but when someone mentioned code visualization, I got reminded of our code object, and then pain again. Rendering Lottie file. Yes, that would also be fun. So in terms of output, but before we can do anything in that direction, we need to rework the existing backend. Is there anything else that I wanted to put here? Yes, I feel like we did talk about this interwoven with all the other points. What should the library try to accomplish? So the core devs say, well, take for mathematical videos. Are there any short feelings in terms of what should the library try to accomplish? Any thoughts that you would like to share before we go on into the next section? That's right, we do use pigments for the code highlighting. I don't recall what take for mathematical animations means. Well, if you're going to write some sort of mathematical text, you usually use LaTeX. And in a similar way, if someone wants to produce a mathematical animation, they should use Manim. How often in general are these meetings? Yes, we could try to, but I think I say that every public meeting. We could try to make these a little bit more frequent. It's just a matter of organizing them. And if there are more people who are willing to moderate and go through stuff, then I think we can also increase it. Oh, that's interesting. I'll read that out later. Okay, let's. I think we can wrap the general goals of Manim discussion up and head to the last part. That's sort of open ended. We'll see how things go. We would like to have eventually a 1.0 release of Manim. The question is, what do we have to do to get there? One thing that you have to know is that the current situation of the internal code is bad. Take the two original versions of Manim, the one with Cairo rendering and the one with OpenGL rendering, both written by Grant, mash them together and then add, a lot of basically cohesive glue from the community trying to polish out things. Try to mash them together and you end up with more or less what we currently have as a code base. There is an awful amount of code duplication between the rendering logic for OpenGL and Cairo objects. There's an awful amount of discrepancy between how the cameras and the renderers work between these two renderers, and it's bad. There is a I can't not show this. There is a diagram which shows the current object class structure, which Citrus Bunch produced for us. It looks like this. I'm not sure I can't show you the full thing at once. Wait. I do need the thing. Oh wait, this is the wrong screen. This is the wrong screen again. Okay, it doesn't want me to. Basically, can I navigate? Yes, I can. All the way over here. So you see all of this basically up to here is everything that inherits from an object. It started on the right screen. You can see it right now, right? Yeah. And everything over here, that's the OpenGL specific code. And basically everything you see over here is duplicated. All of these classes exist already somewhere on the left. The code often, well, similar, sometimes very much different, hard to describe in some cases. Some of these probably can just be deleted without anything. But yeah, so this is part of our problem. This duplication between OpenGL objects and the default objects. We do have a roadmap in our wiki. I will share the link. So this is the link here. I also posted here. We do have a roadmap in our wiki, which where we try to start, well, some ideas and points for discussion for how this a potential rework that makes the library stable enough so that we can, well, add other rendering backends and stuff to it. We've started the discussion there, but it well, did not get extremely far yet. So if you have ideas or want to contribute to that, that's very much welcome. Where's my thing? Oh, I closed it. Here. One concrete plan that we have. Is we go in some sort of maintenance mode. We freeze the merging of pull requests, introducing new features for a while, and it's not clear what while in this context really means. Some sort of rough estimates would be something between 3 and 5 months. I don't know, maybe half a year. Very unclear. Depends on how motivated we are. And in this time, we try to unify these core concepts between the two renderers and make sure to introduce a separate. And in this time, we introduce a separate, or a stable abstract API that all of these currently existing classes that are well, very, very incompatible then implement. So the Cairo renderer on the one hand should implement the same API as the OpenGL renderer, and so on and so forth. One suggestion of how to do this, and this is something that we can discuss. So is every contribution stopped for now? No. Only contributions that introduce completely new features in a sense, or that are interacting with the parts we are rewriting. If you just introduce like a new object or so, we could probably still merge it. But the thing that is going to be difficult is how will we manage, on the one hand, the branch where people probably or hopefully work very fast on, with breaking tests and everything, and on the one hand, and on the other hand, the stable part. This is something that's not quite clear to us yet, how we can really manage that. So yeah, one thing that we could do now is hear what you guys think. How should we do it? Are you okay with basically not getting a new release for a while, or just having one more release before we go into maintenance mode and then waiting, or what should we do?
Can we not just have it so that we release, like, let's say monthly bug fix releases over the length of the refactoring period?
Theoretically, that's possible. The only question is whether we can well handle it. One thing that I thought of was basically we could try to keep the at least bug fix development on the main branch open as it is right now, and merge I don't know, fixes for documentation and stuff, just merge that, but require that every bug that's fixed comes with a test, and then we can use these tests to make sure that whatever we do on the development branch in the end also works. One cleanup release and then a break in order to refactor. That sounds reasonable as long as the refactoring plan is more or less clear beforehand. Yeah, that's the big problem, is the plan is not clear beforehand and probably won't be. It's very hard at this point to say what exactly will happen and what's the direction we'll move in. We have some proposals and ideas for the most important things that should happen within this refactor period, but it's very hard to say if we go there or go there some part of this way, whether we will continue the same way or whether we'll branch off in a different direction at some point.
I think it makes sense to have the refactor, like, because obviously things are gonna have to break if we, remove the duplication and all these unnecessary files that we have. But I'm still not sure whether it warrants completely freezing all new features. Like, for example, the front end API shouldn't really change. So, for example, if someone wants to add a new like component to like axes, for example, or like a new parameter, let's say, that's not something that should be touched by the refactor. So I don't really think it's too harmful if we let something like that get passed through, and it's very unlikely that it introduces a merge conflict that we're gonna have to fight really hard to fix.
Yeah, if I'm allowed to add something to that, I do think that certain parts of Manim won't be touched by this maintenance mode at all, like the front end, as you've mentioned. But if we have any pull request, the core devs have to. I'm very sorry about that. We, the core devs, have to monitor that, have to review those pull requests, and that takes time that we need on the maintenance mode, on the maintenance branch, so that branch can get merged back as quickly as possible. And I think I do think that this maintenance mode makes a lot of sense for this refactor.
Okay, so I think it's hard to say which sort of pull requests we wouldn't accept in during the maintenance mode. I agree that we can probably continue to merge stuff that's unrelated, or where we have the feeling it won't interfere with what we're currently doing. This is sort of unsatisfactory for everyone trying to contribute and adding changing code or adding new features during that time, but I don't really see a way around that to specify hey, your contributions are welcome in general, but it might happen that they can't be considered for now, depending on what exactly you contribute.
Maybe we could just encourage people to contribute to not the main branch of Manim, but to the refactor branch. And then it'd be more easy to tell whether they're directly conflicting with changes that have been made.
Yeah, that probably makes sense. Okay, so in general, I think you guys would like to have continued bug fix releases in some, well, in some period. And I mean, this makes sense. If someone fixes something, it should be available to people sooner or later. Doesn't make sense to hold off on that forever. Do you have the resources to do that? Yeah, that's one big question. If we look at the number of open pull requests right now, they're like, I don't know, 55 plus that are open. Some of them stalled and just that just would require us to close them. Some where the status is unclear. It might make sense to go over them, maybe in another sort of development meeting, and just decide one after the other, close or keep open. I mean, a closed pull request doesn't mean that it doesn't exist anymore, right? If someone, whoever wanted to contribute for the first contribute in the first place, comes back and decides now is the time to make the changes requested, then they can always reopen it and well. But as of right now, there are, I don't know, I haven't gone back to the second page of pull requests for a while now, because I already got stuck on the first page, and then if multiple people contribute and work on the refactor, then yes, I do think we have the resources to do both things at the same time. If it's a matter of like 2 people trying to change the world, then probably not. Okay, so let's keep this resource question a little bit in mind. What have we talked about regarding the refactor? Yeah, what happens to currently open pairs? That's what we just discussed. Some, well, a very, very top level view of things that need to happen before at least on my list, before we can consider releasing a 1.0 version. First, and that's something that I'm very interested in, and I've already spent some time on investigating, unifying the 2 mobjects. So mobject should again be agnostic of the renderer. Mobject and OpenGL mobject should be merged. vMobject and OpenGL vMobject should be merged. And this meta-class business should, if possible, be also removed. That's what I would like to do. Something else that needs to be done is we do need an abstract base class for the renderer, so that whenever we try to switch rendering backends, change rendering backends to something Python internal, to something external, C++, Maki, Chris will show us something in a little bit. Every interface needs to know, a renderer needs to be specified, and we do need to do that somehow, and then we need to stick to it. Scene, just like mobject, should also be agnostic of the renderer. It should not depend on the implementation renderer, scenes should just work. Camera is probably the biggest pain point in all of this, because currently the camera class does a lot of work that actually the Cairo renderer should do, but the camera does it. Is this weird layer in between, converting stuff from 3D to 2D so that Cairo can process it, that Chris mentioned. I think Chris mentioned earlier, and unraveling that and turning that into an actual camera and then an actual renderer, that probably is what will bind quite a lot of resources. And after we've done that, I feel like then we have some sort of clean slate that we can also properly change things around. We can change the renderer, then we can decide on maybe just using one particular renderer and not shipping with 2 default renderers, and so on and so forth.
I think, like, similar to what Daryl Golden's saying in the chat right now, what we could do is like start off with making everything, like getting rid of the duplicated OpenGL object stuff, and essentially making Manim CE as usable as Manim GL in terms of OpenGL interactivity. And then we could start moving on to like abstracting away the renderer and making it so that we could shift any renderer backend. Because like I think the first problem is, I wouldn't say much easier, but like it's just like code that we can we basically just have to polish up and clean up, and it sounds easier than refactoring rendering to make it independent of like which one you choose.
Yeah, exactly. That sounds very reasonable.
And I guess to be more specific about what that would entail, I'm thinking that we basically just move over. We basically make the OpenGL versions of the objects. So OpenGL object.py would become object.py because the code is compatible with OpenGL and is generally cleaner, in my opinion. Also, it would mean, I guess, I'm forgetting the word, like improving the CLI, like the way that things are called and the defaults that we have. Like, for example, to actually run a scene in OpenGL, there's a lot of text that you have to input each time. So we could just make it so that the defaults are sensible in that context.
Yeah.
And that's kind of what I think is like what should be done for the first part of the refactor.
I think that's reasonable. So these are, I think this is I've looked a little bit into object versus OpenGL object, and I think it's not a lost cause at all. But I feel like it would make sense to move more into the direction of how OpenGL object is currently implemented. And I don't even think that this requires to update that many things. I mean, Grant renamed some things, some methods when moving from Cairo to OpenGL, but in general, that should still be pretty compatible, more or less.
Yeah, has Daryl Golden mentioned that we should maybe ditch Cairo entirely? And I think I kind of agree with that. Like, it's not worth keeping Cairo around.
If OpenGL rendering works well, then yes. But at least from my point of view, there are quite a few things that don't work well yet.
Do you have any like key examples? Things that aren't up to speed?
We usually have some graphic specific issues, right? So there were some lines in when rendering with certain GPUs.
Oh, right.
And these are things we understand Cairo well enough to fix that directly, but I feel like we don't really have the OpenGL knowledge in the community right now to well, basically write custom shaders for all of our objects and the things that Grant did. I feel like we can get help with that, definitely.
I think we haven't really talked about the projection shaders that Euler Tour wrote, because I'm pretty sure those don't have the lines not rendering issues.
That's one of the things that we should probably do. We should ditch Grant's current renderers and switch to by default Euler Tour ones.
Yeah, I think like there's an issue with that, which is that they don't. Like for example, he didn't like Euler Tour didn't write the surface shaders, so we only have Grant surface shaders, and Euler Tour's shaders and Grant shaders don't combine well at all. So we need to rewrite the surface shaders basically, which is something to do.
Maybe we can ask Grant to come to an about 3-hour pair programming session with a few core devs, go through the code base and ask him what he thinks is not necessarily. I don't think this is something that we need to do. We've mentioned earlier this project has outgrown Grant, and I think this is the case. And getting him to look at his old code and the community code and trying to figure out what the best direction is, I'm not sure whether that is something that would be that helpful.
Okay, I'm putting on my microphone. I think it would be nice to have like some third person view on the library. So it doesn't have to be Grant. Maybe it can also be people from Matplotlib, because they face the same problems like we do right now. And maybe we can also invite them and ask them what do they think, or what advice do they have for us.
In what terms do you mean they face the same problems as we do?
They also wrote a renderer a few years ago, and yeah, I guess like the process of writing a renderer, for example, like what they think is important in this process, or maybe they have advices for us.
If we have a very very clear idea of what exactly we would discuss with them, then maybe this would make sense. But in general, I'm not sure. We have a community of people that is, I think, happy to give input, judging from how things are going right now, and we should make use of them. Try to involve people a bit more.
Yeah, that sounds good.
So what happened here in the meantime? Slow. Well, two shaders are very buggy. I mean, this is something we have to investigate a bit further. I'm not sure I'm not sure how I'm not sure how solid our current information on this the status of the shaders is. We'll have to. I think we have to investigate it a little bit more. I'm not sure whether it makes sense to discuss that in a meeting right now. This meeting is just a cry for help. No, it's well, also yes, but I think it makes sense to discuss what things to change and how to go about it. I think now we've talked so much about renderers, it might make sense to look at something that Chris has been doing and that we've mentioned numerous times so far. If Chris is still here and available to show something.
Yes, I am. The thing is, I wasn't prepared. I wasn't aware that you can't share a screen on the town hall. Thankfully, Hendrik offered me to use this big blue button side of his university. Maybe
but the thing I would suggest is the following.
That you stream it from Big Blue Button.
No, that you just hop in on the demo channel to below here, and then you start your stream. Wait, actually, how many people are here right now? 21 listening. That works out. We can just move all together to the community meetings channel, and you can broadcast from there.
Oh, well, in that case.
Let's do that. The meeting will continue afterwards in this channel here. We'll move to the community meetings channel for a quick demonstration. Okay.
Okay, I have to set a few things up now that I have access to actually streaming. I want to do a few things differently. Okay.
Just one thing, if you're listening in this channel now, make sure to mute your mics. We can also do it for you if you're too slow.
Okay. The stream is working. I hope. I have to change something. One sec. Okay, that works. So, yeah, okay, first of all, Maki is a rendering backend from Manim, an experimental rendering backend that is using C++. It internally uses OpenGL, but has support for many different rendering APIs like Vulkan, Metal, whatever, but they haven't been implemented yet. But they can rather easily be implemented in the future if we need to. Okay. Even though Maki is written in C++, there is an interface layer so that Python can actually use Maki. And that is the part that I want to show you right now. Yeah. So I'll just... come on. No. It doesn't. There we go. Okay. So, the first thing you have to do when you want to use Maki, if you use this in a separate one. Yeah, I'm very sorry. I'm very rarely using Jupyter Notebook. This is actually one of my first times using this. Okay, so the first thing you have to do is to import Maki. And then Maki is available. All of the marking symbols can be used. Then you have to initiate Maki. The first, I made it. I think it's pretty important that the very first instruction in Maki is to set the rendering API, because this thing is entirely abstracted. Everything, if Vulkan would have been implemented by this time, the only thing you have to do is change this one line, and it would use the Vulkan rendering system instead. So that you don't have to use string comparisons or whatever Manim is doing at the moment to switch between Cairo and OpenGL. Okay, once that has been done, you can create a render driver. A bit tiny. Let me close this. The render driver takes care of, well, handling everything that is supposed to be drawn on the screen. In the end, Maki is not object-oriented, or at least not, the interface is not. It is a state machine, more or less. This object handles everything. It keeps track of all of the atoms, that's how I call them, the smallest rendering units, and all of the changes to move atoms around, and we'll see about that. But this one object, the render driver, is the most important thing that Maki exports. So this opens a window with IMGUI support. That is, well, the raw version of this PyIMGUI, I forgot the name, library that we have talked about before, so that I can actually show some things. So this is showing a frame rate of around 70 frames per second. I could go much higher. I've enabled VSync, which syncs the frame rate of Maki to my monitor, which has a refresh rate of 70 hertz. I actually experimented with turning that off, and my frame counter showed infinite. My graphics card was making strange noises, and all of the movement was dead because apparently the frame time was so small that if a float can't really express it anymore. So I don't think we have to worry about the frame rate at the moment. Okay. This is creating the render driver. Now I can actually use this. I've talked about atoms before. This is how you create them. Render driver.add cuboid atom. At the moment, I've only implemented a single type of atoms, the cuboid, which is just a cube with, well, you can shear it, you can rotate it, you can do very funky things that makes it not a cube anymore. So I can run this and nothing happens. Very similar to Manim, when an atom gets created, it doesn't actually do anything. It only creates it internally. Maki is aware of it. It has allocated space for it. And now you have to, well, you have to tell Maki to actually render it. And I can do that with this command. Maki renderer, render driver dot blah blah blah, render cuboid atom. And this is taking this cuboid. The cuboid isn't actually a real object. It's just an integer. It's just a handle with which you can address this one cuboid. Very true to this state machine aspect of Maki. And I'm telling it to render it in the first frame, which is not the 0th frame, but the first frame. And I'm telling it to please render it, so true. When I do this, you see on the right that my frame slider here grew a little. This is the first frame. This is the first one. Well, the 0th and the first one. And you can see that I can move around really freely, and I can, well, I can speed this up a bit. And I can jump from the 0th frame to the first one. Okay. Now I can do a few more funky things. Like, I can give it a color. Like this. And you see that we have a third frame. We have the 0th frame, the first one, and the second. What I'm doing here is invoking a new function, color cuboid atom, which is coloring this one cuboid. I could theoretically color each vertex on its own and give it some kind of color shifting effect, but right now I haven't implemented that yet, or at least I haven't implemented this function to support that. I'm giving it this RGBA value for the actual color. The thing is, right now, in the future, I want to use NumPy for this. At the moment, I'm using this toy implementation of a vector, Maki.vec4, which actually doesn't support anything except for creation and scaling. It doesn't do anything but that. But for simple examples, it should be enough. So I can do this, and oh, actually, just that's another feature. I accidentally ran this command twice, which is perfectly fine from Maki. Maki detects that and handles it appropriately. So now I have 3 frames. I have nothing, white cube, and yellow cube. Okay, and I can do a bit more of that. Now I'm changing the color 3 more times in the 3rd, 4th, and 5th frame. And I subsequently get more frames. So nothing, white, yellow, then a few more funky colors. And I can just jump to any point in this thing. And Manim, or the Python code, doesn't have to bother with any of that. That is something Maki is aware of, Maki can handle. This entire timeline thing is completely opaque to the Python code because it doesn't need that. Okay, now I can do the last function that I've implemented is the translation. So now I'm translating this cube in the 6th frame, and you see it moves, it goes up. Okay, I can do that. But that is a bit harsh, this jump. So I've done a bit of Python magic. If we actually were to use Maki for Manim, that is something I think Manim should take care of, not Maki. Maki doesn't really care about any animation. It only cares about those atoms and how they directly change from frame to frame. So this is a very, it is just a smooth transition, a linear animation, moving this one object from the frame 60 to the frame 200, and moves it 10 units to the right, 10 units up, and 5 units into the screen. Okay, I have to back off a bit, and you see my my frame bar has extended again. And when I do this, it actually moves. It actually does this. Okay. Now we can do a few more funky things. How to teach Manim time travel. The thing is, right now, when you are using Cairo, for example, or when the way Manim works, is it starts reading the scene, starts from the beginning, and then executes one instruction after another. That means that there is some kind of chronology. You start in the beginning, you end in the end. You can't time travel because for every frame you are rendering the entire frame, saving it to disk, and you can't touch it again. That is something. Well, time isn't something Maki, a user of Maki, has to bother with. So we can do this. This is basically the same code as before, just with the different values. So now I'm moving from frame 5 to frame 50, and I move it 5 units down, and I again apply this linear thing. But right now I'm at frame 195, which is, well, in the present, but I'm changing something in the past. When I run this, it actually moves down. So we have changed the past, and we see the effect in the present. That is what this time travel thing is, what the heading is all about. And this one message, ChronoSync initiated, the name is not very technical, I just liked it. That is the most important function, the most important feature of Maki that actually allows this, this time jumping. Okay, I'll answer questions later on. Right now, I just want to go through a few features. Okay, now everyone likes to see familiar faces, right? Let's implement mobjects. Mobjects in this case are just wrapper objects around those atoms. In the end, they would be a lot more complicated. If this would actually be the new rendering backend from Manim, then they would obviously have a lot more information than this is. And this is really just a very, very, very quick showcase of what could theoretically be done. What I'm doing is create this abstract mobject class. I have an implementation of that, which is a cube. I am creating the cube. I am giving it the render driver, and the first frame, which is when the cube should be shown. I can show the cube, I can hide the cube, and I can move it around. Okay, now we can actually use this. There we go. We've just added a cube in the past, and we see it in the present. So if we move back to the very first frame, we don't see anything. If we go to frame 5, it actually appears. This weird graphics glitch is because there are two faces in the same position, and OpenGL doesn't quite know which one should be rendered, so it just does this instead. Yeah, that is something you can't really fix. You have to write code that actually is aware of this. Okay, so now I can use the function I've used like this. And now I'm translating it from frame 10 to 300. So this function I have defined twice over here, this animation, this translation thing, is abstracted away in this translate function or method. And it is being applied from frame 10 to frame 300 and is moving it 200 units away from the screen. So if I go there, you can see the white cube is moving while the purple one is still moving. I haven't changed anything about that, so Maki just does whatever it well, did before. Okay. Now another thing. I have This is some code I ripped out of an old project of mine. The thing is, it was working perfectly fine until half an hour before the town hall, and then it just started crashing 2 out of 3 times. So I'll just have to restart it a few times if it doesn't work immediately, which I'm very sorry about, but I can't help it. I'm sorry. So what this does is it creates a new object, a text cubes. What it does, we'll see in a moment. Let's see if this works. It actually does. Cool. Okay, so I can actually make this full screen. This is just some kind of animation showing the versatility of Maki. I'm just creating those atoms, those cubes. I moving them into this hello world shape, and then I color them with random colors. And well, while this is actually running, I can just go wherever I want and look at it from a different angle. And we see it from a different angle. And while all of this is happening, those other 2 cubes here, the white one and the purple one, are still doing its thing. Maki is aware of it. The Python code, well, who knows if the Python code is aware of it? It just happens. Python doesn't have to actually know that they're there. They just are. Yeah, I think I should. I hope there are a few questions I can answer in the meetings chat. Yeah, I can go into depth of how this actually works under the hood in a moment. I just wanted to show you what the current feature set is like.
Yeah, I mean, for now, thank you for the very interesting demonstration.
Okay, very long or complicated scenes. Will it run out of memory? No, I don't think so. I've actually I can show you something. I did a little I don't know if I put that in Manim showcase. Here. You can use Maki from Python and from C++. I wrote the C++ thing just because, well, quick debugging. I don't want to implement this interface layer every time I'm changing something. So I wrote this little stub program that hopefully works. Yeah, it seems like it's working. Which is, well, basically testing the limits of Maki, and this is a total of 125,000 cubes being rendered and destructed. Being rendered and created and destroyed in a matter of milliseconds. The frame rate is still going strong. Yeah, I should. Again, I should play around with some vsync stuff, but I haven't done that yet.
Does that require a graphics card? Or can you also run this on a laptop?
Well, if your laptop has a desktop, it can run this. A desktop is still a graphical application. If you are running this on a system that doesn't have any graphical unit at all, like a server, then you have to use a software implementation or software driver like Mesa or Gallium on Linux. They can also make this work on a GPU-less system. But obviously, if you want the full performance, use a graphics card. Manim is a graphical library. It makes sense for it to utilize the graphics card.
Okay, thanks.
Okay, I think I can talk a bit about the internals. Yeah, so I split this entire project into multiple parts. Maki, Maki Core, and the stub. I've already shown you the stub. Maki is just the interface layer to the Maki Core, and Maki Core has all of the interesting code. So the renderer is fully abstracted. So I have abstract classes for everything, like the buffers. Those are all abstract classes, everything in C++, of course. And I have implementations in OpenGL at the moment. So if we want to support something like Vulkan or DirectX, the only thing, quote unquote, only thing we have to do is re-implement this one folder for Vulkan, DirectX, or whatever. And then it should work just as normal. The entire, every other part of Maki is entirely agnostic of the renderer. It doesn't care what kind of rendering system is being used internally or under the hood. Okay, that is the renderer. Then I have this platform thing. The platform part is basically the system that allows me to open a window and catch all of those input callbacks, inputs, so that when I press W, I actually move forward, and when I press S, I'm moving backwards. That's what the platform allows. And we might have to use different platforms. GLFW works on Linux, Mac, Windows, but as far as I know, it doesn't really work on the web. So if we want to add web support for this, which is theoretically possible with WebGL, then we'd have to use something else, maybe SDL or something comparable to that. Yeah. One interesting fact about the platform is that while the renderer is chosen at runtime, so if you are installing Maki, you have all of the renderers installed. You have OpenGL, you have Vulkan, everything that has been implemented. Why? Because sometimes you might want to use a different renderer, even though another one is available in your system. So OpenGL, for example, and DirectX are both available in on Windows. But if for whatever reason you have written custom shaders for Maki that only work with OpenGL, so you've written them in GLSL, then they won't work on DirectX. So you must at least somehow be able to change the rendering API, and that's actually something you, if I open the right window, you can see here Maki init. So I'm setting the implementation at runtime. That is different for the platform because you have to compile this. C++ is a compiled language. You have to compile it for Windows or for Linux or for Mac or for web. That means that when you're compiling for Linux, you know that you don't need web support. You only need GLFW, not SDL. If you're compiling for the web, you don't need GLFW because that is never going to be used. So you can remove that slight runtime overhead to choose the right, the right rendering API or the right platform. So this is the difference between the OpenGL rendering abstraction and the platform abstraction is that the platform abstraction is compile time. It is being decided when you're actually compiling this thing. Okay, the driver is a system that basically drives the renderer. It drives the camera, it drives the renderer, it tells it what needs to be done. So, well, why am I splitting this up into a different directory? Because this is code that works for all rendering APIs. It works for Vulkan or OpenGL, so it doesn't make sense to re-implement it for every more low-level renderer. So for example, here we've already talked about the camera. This is the camera driver. It's very simple. It only detects those key presses and forwards that that data to the actual camera, which is currently implemented here. So wait, I can show you this file instead. So this is very simple. It only takes the position of the camera, the rotation, the point the camera is looking at, so the direction vector, and the up vector, so in which direction is up. If you want to flip your monitor around, then you just have to flip that up vector around. And there are a bunch of functions connected to that. I'm using some caching to optimize all of this, but that is not too important at the moment. But yeah, this is the entire camera class. Everything that is required to show a different angle from your scene. Okay, so the driver, here's the render driver, which you've already seen on the Python end. And here you can see those functions that I've used. Add cuboid atom, render cuboid atom, translate cuboid atom, color cuboid atom. They're defined here, and if I want more, I can just use them here. Okay, the actual interesting bit, the atoms. One option to make all of this work is to have one huge array of atoms. I call an array of atoms an atom chain. So one frame consists out of one atom chain. That is all of the atoms that are supposed to be rendered on this frame. If you want to represent multiple frames, the easiest thing to do would be to just have multiple atom chains, one for each frame. But that is obviously incredibly expensive memory-wise, and well, the CPU is mostly fine, but memory will absolutely kill you if you did that. So that's not what I'm doing. Instead, I am storing the differences from the last frame to the current frame. I call those the atom diffs, which are classes, objects that describe how an atom can be changed from the last frame to the current frame. And these atom diffs have two functions, reverse and apply. Apply takes the old atom more or less and moves it over into the current frame. The reverse function does the exact opposite. So I can move it back. That allows me to very quickly jump through, very quickly scan through the entire scene. If I'm going forward, I'm just applying all of those apply functions. If I'm going backwards, I'm applying all of those reverse functions. Well, the internal functions of Maki are smart enough to just know what needs to be done. You just give it a frame. I want to go to frame 122, and it just does whatever is required to get there. Maki does that. Manim doesn't have to think about this at all. Okay, those are the atom diffs. Those atom diffs are then again stored in those atom diff frames. There's a lot of new terminology here, but it's necessary to make this fast and, well, generally sensible. So these atom diff frames have a collection of multiple atom diffs, and it has all of the functions required to actually apply those atom diffs. And then I have the entire atom diff lifetime, which has a bunch of those atom diff frames and is applying those whenever necessary. So it has some
Chris?
kind of... Yes?
One question before we drift off into too technical details that are a bit hard to follow. What if we said we mirrored this implementation on the Python end of things? So instead of, implementing this sort of differences between frames is something that we could do in Python as well. And then this would allow, theoretically, Manim and Manim's renderer also to do these sort of things without relying on anything that's too externalized, right?
Well, theoretically you can do that. It just won't be very fast. I've decided on this implementation. I've chosen this implementation based on the language being used, in this case C++. So I'm using a lot of compile time optimization. I'm using a lot of, well, in C++ you call them templates, with which you can basically compute things at compile time. You don't have to do it at runtime.
We currently, in the current implementation, Manim simply steps through every frame anyways. And storing this information somehow, what changes between frames somewhere, cannot be that much of an overhead. So I don't think this would be extremely complicated to do it on the Python end of things, or extremely slow. I don't think that. But this is something that we would have to try out anyways. I don't have any measurements or anything to support that, of course.
Yeah.
And
I myself haven't done any real benchmarks on Maki at the moment. So far everything is just working well.
Yeah, so I think this needs some experience, but I think of course the general interface that you created and Maki in general is very impressive. No doubt about that. No doubt about that. But I just wonder how much can we do before we move out of and go full way including a C++ project as the renderer. How much can we do inside of Manim with our current tools and setups?
Yeah, that is obviously a valid question. I've made this project just to play around to see what can be done, and of course, most of these things can in some way be implemented in Python, obviously.
Yeah, I mean, it's just something we could try out. And I mean, if we say that the abstract renderer class that we want to introduce anyways, if we just take precautions that this can be added to it, then why not, right? We could still include some sort of mechanism that externalizes this moving through the atom chain to an external renderer, but in theory we could also do it.
Yeah, I mean, my main point is that I think that C++ makes quite a lot of sense for this very, very low level work on the rendering. You have very, very, very strict typing. You are forced to respect that abstraction system you have built. Like right now, I wouldn't even be able to just implement another secondary renderer that is not part of this abstraction system. I have to use it. And in Python, you have a lot more freedom to do that, which is the main reason why I use C++ for experimenting, because it forces me to write a clean abstraction layer. And if we just copy that over into Python, and we still have this clean abstraction, then that would also work. It's just we have to see if that makes sense. And well, if we for some reason have to implement the backend rendering in C++ anyways, then I think that it makes sense to implement any kind of atom chain memory optimization, whatever, in C++ as well, so that Manim has less to worry about. That is something I like quite a bit about the current implementation, that the C++ code is very minimal. It doesn't have to bother with any of the internals. Maki does all of that. Maki takes care that everything is fast and optimized and all that stuff.
Yeah, definitely. No, I think all of this is great. We just need to look into stuff and experiment a bit more.
Yeah, exactly.
All right. If you don't mind, I would forcefully cut you off now at this point.
Yeah, sure.
Thank you so much again for your demonstration. This was really very, very interesting. We could, if you want, move back to the community channel, but the last thing I more or less have anyways is the let me open it on my stream, is the any other business. So I think for the meeting in general, we are done with everything that we needed to address or we wanted to discuss with the public, and now all that remains is, well, anything else that's on your mind. Comments, questions? Also, of course, more comments and questions for Chris and his walkthrough, Maki.
Oh yeah, and if anyone is interested in the code, everything is obviously on GitHub. So here.
I still want to talk about how we plan on fixing this. This being the scene play call diagram. Yeah, be more precise. What exactly do you mean? I mean, parts of it definitely. It's hard to discuss in detail what exactly we should change between the current implementation and the future one, because it's just requires people to sit down and actually draft abstract base classes, and we can't really do that productively in a big meeting like that. I don't think that would work out. But we need proposals for abstract base classes from objects, the scene, camera, renderer, and then we go from there. Some of the work will become more obvious as soon as we resolve the current mess with object versus OpenGL object, because then it becomes clearer what sort of methods will an object have, how does the scene have to interact with an object at all, and so on and so forth. So these things will clarify. I'm pretty sure. Does the new feature block start today, or are we going to try go through and merge or close everything first? I think we in the roadmap there is a proposed date of the 21st of January. Someone correct me if I'm wrong. So until then, help with reviewing open PRs, merging is definitely appreciated. Whether we do a release before freezing or how that will work out, we'll figure that out when we get there. Probably a new release. Thanks, Daryl. Any further questions that we should discuss now that we are all here right now? Or anything in general that you would like to discuss? Should we be using a model like reactive programming, model view controller, etc.? I don't have a strong opinion about that. How do we go about allocating the work? I also don't have a strong opinion about that. Usually things happen. We need people that feel responsible for some of the things. I, for example, feel responsible for the objects. I think Ryan did some work on the scene already, and we could start from there and then do stuff. I think Chris has definitely thought about renderer. I don't know whether you've thought about abstract, how an abstract renderer class in Manim could look like.
Well, in general, yes, but not well, referring to the current implementation, how we can easily. Right now, I'm basically in. I do whatever I want. I want this to be like that. I want C++. I want abstract. I want compile time optimization. So I just do it. I haven't really thought that much about actually well doing this in Python, so that we don't have to rewrite that much. Because right now this is very radical. I completely agree with that. We'd have to throw away a lot of code if we really want to use Maki, which we probably don't. So, you know.
yeah, so I guess we start making proposals and then we get to work. There's not really much more I can say about allocating. If we don't break stuff too much throughout the release, then we can still keep making releases. I think we mentioned that we could have bug fix releases certainly, but work will still happen on the development branch. I think as the first step of introducing abstract base classes for the core concepts is a reasonable thing and something that's probably quite achievable. Abstract base classes and then making sure that the existing implementations adhere to those, and then we'll go from there. Releases from the development branch. If stuff is not broken, maybe. But I'm not sure whether that's a good idea. I guess we can do pre-releases and then alpha or something like that. Was the talk about when we were freezing and making a branch? I missed that. If there is a proposed date in the our roadmap wiki. I think it's the 21st of January. I thought that you meant January 2022. Yes. Currently, only Maki is able to travel back in time. So I would say let's do that. Let's try to clean up the repository a bit more until then, and especially close open pull requests that are not going to be merged, or try to review and merge the ones that are currently open, and then yeah, get to work. If someone wants to propose, so we have our architecture discussions channel on Discord, where quite a lot of things happened recently. If someone wants to propose how certain things can be unified, or abstract base classes for things, then feel free to send messages there or create discussions on GitHub. Maybe it's a bit more less fast and less likely to get lost. But other than that, I don't really think that there are any other things that we need to discuss right now. Anything else that someone wants to speak about? Making any decisions is hard if there are no pre-written proposals. So if you feel like you have something to contribute to the development process, then please write up your thoughts in a paragraph or two, and then send it to one of the channels, and then we can see what people think about it. Ad hoc, it's hard to make decisions like that, and coming up with proposals on stream is even, or during the meeting is also hard. Recorded some rough notes here. Oh, great. Yes, please add notes to the either the roadmap wiki or we can also include it in our Nuclino in the agenda thing that we use. But then, yeah, I think that's more or less it for this meeting. If there are no further comments, thanks everyone here for hanging around and participating, and for contributing your thoughts. This was, I enjoyed it. I hope you did as well. And yeah, thanks to everyone who presented their thoughts and something to say. Looking forward to seeing you on our server some more. And yeah, have a great day. Bye, everyone. Well, and that's also it for Twitch stream today. Thanks everyone for watching. If you liked that, I sometimes do a little bit of Manim coding on stream. And sometimes we also just chat or play games. So follow if you liked that sort of stuff. And yeah, see you next time. Bye-bye.